Tuesday solutions video to that nice little review assignment I gave you guys over the long weekend after you took your test. So use this. I'm going to work out every problem. Feel free to fast forward if you got it. Totally up to you. For number 1, it gave us a right triangle and it asked us which ratio represents the sine of u. Alright, so for this we're using Sohcahtoa, so I'll write that at the top here. Sohcahtoa. I learned lots of ways to remember this. Something about Oscar had a heap of apples. I just preferred Sohcahtoa. Some old hippie, another hippie tripping on acid, whichever you prefer. Alright, but we want the sine of u. Sine is opposite over hypotenuse. So looking at the angle u, the opposite side has a length of 15. And the hypotenuse, which is the side across from the right angle, is 17. So the sine of u is choice 2, 15 over 17. For number 2, you wanted the sine of x. All right, again, sine is opposite over hypotenuse. Looking at the angle x, the side that is opposite of it has a length of 28. And the hypotenuse, which is across from the right angle, has a length of 53. So this is going to be choice 1, 28 over 53. Looking at number 3, we wanted to know the cosine of angle A. Angle A is in the bottom right. Cosine is adjacent over hypotenuse. The side that is adjacent to angle A is 3. Remember, adjacent means next to, and the hypotenuse, which is across from the right angle, is 5. So your answer is choice 1, 3 over 5, 3/5. For number 4, we are looking at the cosine of A. Again, adjacent over hypotenuse. Looking at A, the adjacent side is 5. Alright, be careful. Do not think that the adjacent side is 13. I know that 5 and 13 are both next to angle A, but 13 is also across from the right angle, so 13 is the hypotenuse. Okay, just because both sides are technically adjacent, hypotenuse kind of trumps adjacent. So the answer is choice 1, 5 over 13. For number 5, we wanted, again, the cosine of A. Looking at angle A, this triangle is kind of funky because it's flipped. We want the adjacent side of A, which is going to be 16. Adjacent means next to, over the hypotenuse. Hypotenuse is across from the right angle, which has a length of 20. Alright, that was choice 2, but remember we love to go to cancel 10 in this class, so if this were a long answer problem, I would really like you guys to write this as 4/5. Alright, both are divisible by 4, remember that. Flip the page, because that was the front. Now we are on number 6. They give you all that info, but they also labeled the drawing for you, so that's nice. Now we're doing the tangent of 60. Tangent is opposite over adjacent. I'm sorry, the tan of C. So I look at angle C. The side opposite of angle C has a measure of 8. The side adjacent to C has a measure of 15. So the tangent of C is 8/15. Do not say that the adjacent side is 17. Alright, choice 3 is not correct. Remember, hypotenuse trumps adjacent. For number 7, alright, you gotta be careful. It gives you angle ABC. I will actually draw this one. Alright, so for 7, here's my triangle. They give me my right angle, C, A, B, here's 5, here's 12, here's 13. Angle CAB or ABC, you gotta go in order. So I'm here at A, then I go down to B, and then I go to C. Alright, A, B, C. That means I'm talking about this angle. I'm talking about angle B. There is more than one way to name an angle. You guys learned that last year. So if I'm looking at angle ABC and I want tangent, tangent is opposite over adjacent. Opposite side is 5, adjacent side is 12, it's choice 2. For number 8, same thing, alright? They give you the triangle, they tell you angle PLM. Let me draw my triangle. Boop. Here's M, L, P, 4, 5, 3. Remember, 3, 4, 5. That's a really nice right triangle. Angle PLM. I start at P, I go to L, and then I go down to M. So I'm looking at this angle right here. The tangent of that tangent is opposite. The opposite side is 4 over adjacent, which is 3. So the answer is choice 3, 4/3. Let me move the page. Boop. For number 9, come over here, 9. They want us to find the tangent of B. So you look, tangent is opposite. Maybe I'll write that on the top. I'll write my Sohcahtoa. Tangent is opposite over adjacent. So I look at angle B. The opposite side is 8. The adjacent side is 15. Notice 8/15 is not a choice. So you need to put 8 over 15 in your calculator and you will get the decimal of 0.5333. So the answer is choice 2. We should all know that I strongly dislike this answer because it involves decimals. Alright, remember, I'm going to use these swirly equal signs. That means approximately. Okay, but the answer was choice 2. For the next 2 questions, you had to be careful because they didn't actually give you the picture. You needed to make it on your own. So we know I've got a triangle. It says we're going to use MCT, and angle T has 90 degrees. So it's kind of normal to put your right angle in the bottom left. It's totally up to you. And I know that that's a T. Alright, now be careful. Usually, actually, really, triangles are labeled clockwise. So if this goes MCT, that means I need MCT. Because if I go around like a clock, that is how they gave it to me in the problem. Alright, it says that MC is 85, CT is 84, and TM is 13. Okay, and this should kind of confirm that you made the right choice because the hypotenuse should always be the longest side. So if you were somehow getting that 13 was across from the right angle, you know that something's up, okay? The hypotenuse always has to be the longest side. So now that I have my triangle, I can look, I want the sine of C. So here is angle C. The sine is the opposite side, which is 13, over the hypotenuse, which is 85. So choice 1, 13 over 85. Question 11, you need to make the drawing. We have triangle ABC. And it says that B is where my 90 degrees is. Alright? If I'm going to do this clockwise, it means that my A needs to be here and my C needs to be here. If you go around like a clock, it should look like it does in the directions. It says that AC is 50, AB is 48, and BC is 14. Okay, so, and again, this makes sense because the longest side is my hypotenuse, so you should know that you did it right. Now we're doing the tangent of A. Here's A. Tangent is opposite, which is going to be 14, over adjacent, which is 48. Alright, and that is choice 2. We all know how to reduce that, hopefully. Question 12, they ask which is correct. Okay, so you need to go through and look. Is the sine of A 15 over 17? No. because the side that's opposite of A is 8. So that's not correct. Choice 2 is also not correct. The tangent of A, if I look, tangent is opposite over adjacent. That should be 8 over 15. So choice 3 is not correct. If you look at choice 2 is not correct. If you look at choice 3, I've got the cosine of A. That means I'm doing adjacent. The adjacent side is 15 over the hypotenuse. The hypotenuse is 17. So choice 3 is correct. So for number 12, we want choice 3. For 13, again, they give us a statement, but they don't actually give us a picture. It helps if you draw the picture. We've got triangle ABCD. And C is where my 90-degree angle is. So here's my C, meaning this is A and this is B, because I need to go around clockwise. It tells me that AB is 5 and AC is 4. We need to figure out which one is not true. Okay, now some of you might be thinking, well, I don't know that other side length. We could use the Pythagorean theorem, or you can look and say, you know that we have these fancy 3, 4, 5 triangles. That's what we call a Pythagorean triple. Okay, but let's see if we even needed to know that that other side was 3. So let's look. My first choice says that the cosine of A is equal to 4/5. Well, let's look at angle A. If I look at angle A, cosine is adjacent over hypotenuse. So adjacent is 4, hypotenuse is 5. This one works. All right, it didn't even use the side BC. So now let's look at number 2. 2 is the tangent of A is equal to 3/4. If I look at the tangent of A, tangent is going to be opposite over adjacent, which is 3/4. Now this one works. That one is true. Remember, we're looking for what is not true. If we look at choice 3, it gives me that the sine of B is equal to 4/5. So now looking at angle B, the opposite side is 4, the hypotenuse side is 5, so this one works as well. So that means 4 cannot be true, and it is in fact not true because the tangent of B would be 4/3, not 5/3. All right, so you can go through and test all those. Make sure you pay attention to the directions. We're looking for what's not true. So don't test choice 1. You see that it works and circle it. All right, read the directions. Wanted to check my time. Now let's flip. All right, remember the next page printed kind of funky, but you only had to do those questions that were on the right-hand side. Number 1 asks which values of x are in the solution set for the following system. All right, and it gives us y is equal to 3x minus 6 and y is equal to x squared minus x minus 6. There are 2 ways to do this. What most of you, I'm sure, did is that you put this into the graph part of your calculator, and then you went in and looked at the table and looked where it was equal for the y values. All right, you should have got that you had equal values at choice 2. X equals 0 and x equals 4. All right, and that is an okay way to do this because it was a multiple choice question. However, we can ask you to do it algebraically, where you have to show some work. When it says you have to do it algebraically, you cannot write down, I put it in my calculator. Okay, you need to actually do the algebra. That's why it's called an algebraic solution. So if we do this algebraically, we look at this and we say, well, I have that y is equal to this and y is equal to this. If y is equal to both of those things, that means both of those things need to be equal to each other. Alright, this is like substitution. You're taking what y is equal to and you're plugging it in for y in the other equation. So this gives me 3x minus 6 is equal to x squared minus x minus 6. Now we have a quadratic, and whenever we want to solve a quadratic, we want to get it equal to 0 so we can factor. So I'll move everything over. I'm going to get 0 is equal to x squared minus 4x. Alright, I subtracted the 3x over and I added the 6 over. Now, when I'm solving this, remember the first thing we look for when we factor is the GCF. I have a GCF of x, and I'm left with x minus 4. Zero product property says that if I have two things multiplied together that give me 0, that either means the first thing equals 0 or the second thing equals 0. So I can get x is equal to 0 or x is equal to 4. The same thing that you got when you just looked at the table in your calculator. Now number 2, you also could have done the same way by putting it into your calculator, but it says determine algebraically, so you should show some work. And they give us x times y is equal to 10, and y is equal to x plus 3. I know that we all probably wanted to get these both solved for y, which you can do. Alright, but if you do that on the left side, you would have to divide both sides by x, and you get 10 divided by x. And that's a fraction that's a little messy. You can work with it, but it's messy. So I'm going to be smart about this, and I'm going to avoid the messy solution. Instead of solving the other one for y, I'm just going to use the fact that this equation on the right is already solved for y. And since I know that y is equal to x plus 3, I'm going to take x plus 3 and substitute it in to the other equation. So that is going to become x times x plus 3 is equal to 10. And now, if we distribute, that becomes x squared plus 3x equals 10. And boom, baby, there's another quadratic that we can solve by getting it equal to 0 and factoring. I hope you guys are starting to notice a pattern that you're probably going to do some stuff that gives you a quadratic and you're going to have to factor. I told you, factoring was a really big deal. To factor this breaks into x plus 5 and x minus 2. And the zero product property says that if two things multiply together to give you 0, the first one is equal to 0, or the second one is equal to 0. So I get that x is equal to negative 5, or x is equal to 2. Now what did it ask me? Determine the x coordinate. Alright, I found the x's. I'm good. That's it. I'm done. Next question. Solve algebraically. And we have 5 is equal to y minus x, and 4x squared equals negative 17x plus y plus 4. Okay, now here you can't just punch this into your calculator. First off, you would have to solve both of them for y. Okay, but it says it wants it algebraically. In this case, you can solve both of them for y because it's not going to give you messed up fractions. Or you can do substitution like we did in the other one. Either way, you're going to get the same answer. Alright, what I'm going to do is I'm just going to use substitution. So for this first one, I'm going to add the x over, and I'm going to get that 5 plus x is equal to y. And then I'm going to take that, since that is what y is equal to, and I'm going to substitute that in to my other equation. And I get 4x squared is equal to negative 17x plus 5 plus x plus 4. We have a quadratic equation. Let's try and get this equal to 0 and factor. Or if you don't feel like doing that, you are more than welcome to use the quadratic formula. If I move everything over, well, first I'll combine some like terms. I'm going to get 4x squared is equal to, it's going to be negative 16x plus 9. And then I can get that equal to 0. 4x squared plus 16x minus 9 equals 0. This is going to factor into 2x and 2x. And I'm going to have 2x minus 1 and 2x plus 9. All right, I'll erase that so it looks a little better. And the zero product property says, by two things multiplied together to give me 0, it means that the first thing is equal to 0, or the second thing is equal to 0. Add 1 divided by 2, I get x is equal to 1/2, or subtract 9 divided by 2, x is equal to negative 9/2. You leave it like this, do not write it as a decimal. Now in this case, I'm not done. It wanted me to actually solve it. Okay, so this means I need to find the y value that goes along with this x and the y value that goes along with that x. You just get that by plugging in to probably this equation up here. Alright, because if you plug in for x, it'll tell you what y is. When you do that, you should get the point 1/2, 11/2, and the point negative 9/2, 1/2. Alright, I'll write that nicer. That was 1/2, 11/2. Okay, very similar to those linear systems that you guys did a while ago, except now we're just throwing that quadratic in there. Four, 5, and 6, you can put these into your calculator. For 4, you're going to get 1 point of intersection. For 5 and 6, you're going to get 2 points of intersection. Okay, now I'll do one of them, and hopefully that'll show you how to do the other ones. For number 4, if you didn't want to put this in your calculator and you wanted to do it algebraically, I've got x squared plus y squared equals 16, and I've got y is equal to 4. Okay, the top is a circle with center at 0, 0 and a radius of 4. The second equation is a horizontal line that has a 0 slope. Announcements. Let's pause.
An announcement from Mr.
Alright, and I'm back. So, it would be really messy to solve that top one for y, but the bottom one already is, so we can use some substitution. Take this 4, plug it in. So you get x squared plus 4 squared is equal to 16. So I get x squared is equal to 0, and that's just 0. Alright, so I've got one x value, so 1 point that's going to hit. Alright, and if you want to think about it graphically, this is going to be the worst circle to draw on the man. Alright, but I've got this circle, and it's got a radius of 4. So there's 4, that's negative 4, and that's negative 4. And this circle hits all of those because it's got a radius of 4. Well, the line y equals 4 is right here. So it's only going to touch once. Alright, so that was question 4. The answer was choice 1. For question 5 and question 6, you would do them very similarly, and you would get choice 2 for 5 and choice 2 for 6. And booyah, I'm done. Peace out.